All right, AMP1 students, in this video we are going to talk about the anatomy of bones, and we're going to start more with the gross structures, those things that we can see without the help of a microscope. So in our objectives, we are going to identify the diaphysis, the epiphysis, medullary or medullary cavity, compact bone, spongy bone, epiphyseal plate or line, nutrient foramen, periosteum, and endosteum. So those are the structures that we need to be able to identify when we're looking at a bone, and also kind of explain what those structures do, primarily as functions, or what they're made up of too, what kind of cells or tissues. So, okay, so in our textbook, we have a picture here of a long bone, and you can see it's of the humerus. And so in part of it, at the top, they kind of did a frontal or coronal section through it, so that way we can see the inside. And then down at the bottom, they kept everything intact, so we can look at that as well. So, okay, so we'll start with the diaphysis. And the diaphysis just is the technical name for the shaft of the bone. So that's going to be that middle part of a long bone that's very slender and narrow, and it's located in the middle. And then the epiphyses, those are going to be the ends of any long bone. So we'll have a proximal epiphysis, and we'll have a distal epiphysis. And so those are going to be the areas at the end that are a little bit more rounded. They have various shapes depending on what long bone we're talking about. So this is kind of what the proximal epiphysis of the humerus looks like. And then the distal epiphysis of the humerus is down here. So, and it starts to just get a little bit wider. It's not as narrow or thin as the diaphysis part. And then if you look at the middle of the diaphysis, there will be a canal. So there's like an open space that runs down the center of the diaphysis. And so that's what they call the medullary or medullary cavity. And it's not empty. It doesn't have bone tissue in there, but it generally is, there is tissue that we'll talk about that's located in that space. But it's that middle part of our diaphysis, kind of that open area that runs down the middle. So we'll talk more about that structure. All right, and then our next structure, and I'm going to go back to our objectives so I can kind of keep going in the right order so I don't forget anything. So we'll talk about the compact bone and the spongy bone, and those are I think we've mentioned that in a previous objective. So that compact bone is that more dense bone that doesn't have any spaces. It's solid, kind of white looking, and it's on the external surface of our bones. So it's going to be more superficial. And then and it's going to be a lot thicker along the diaphysis. So that's a good place to locate it. But just realize it does cover the epiphyses as well. And then the spongy bone, there's a lot more of it in the epiphyses and a little bit less of it down in the diaphysis. There is some, but it's definitely not as much running down there. So, and that's that porous looking bone, the bone that has the open spaces in it. So it looks like a sponge. So they call it spongy bone. All right, and then we'll do the epiphyseal line. So if we were to take an X-ray of our bones, especially it's a lot more evident when we're younger and not all of we're still growing. We'll have this evidence of an area that's in the epiphysis, kind of between the epiphysis and the diaphysis, and it is an area where cartilage will be remaining there until our bones get to the proper length that they have the potential to be. So, and then after that point, after the person has reached their height, then the epiphyseal plate that's made of a cartilage, that cartilage will then be converted into completely bone. And you can actually see a line, kind of like the remnant of that, where that growth plate or epiphyseal plate happened and where the growth of the long bone occurred. So that's in a epiphyseal line. All right, and then the nutrient foramen is another structure. They're just showing one on here. So it's kind of, this is a blood vessel here. Looks like an artery. And there is a little hole in the side of this humerus bone. And then the reason we have that hole there is so that blood vessels can pass through it. Nerves can also do that as well. But in this case, we're looking at just the blood vessel coming through that hole. So remember foramen, that's that term that we use a lot when we're talking about the surface markings on bones. Anytime there's a hole in a bone, they'll use the term generally foramen for that. So they call this bone in the humerus, and realize that all the femur would have one or two or more, and the radius. So every bone's going to have like a hole in it where the blood vessels can pass through, so that way we can get blood into the inside that bone, because we have living cells in here that need to have nutrients and oxygen, so they got to be able to get in there some way. So they call it a foramen because it's a hole, and then they call it nutrient foramen because the blood is carrying nutrients that the cells need that are in our bones. So that's the example of a nutrient foramen, what they're depicting there. All right, let me go back to our objectives. Okay, and then the last two structures that you should be familiar with, and it's a little bit difficult to visualize these, but the first one is called the periosteum. So peri means around, and of course osteum is referring to our bones. So around our bones, on the outside of our bones, like covering the compact bone, there is this like thin connective tissue, and it's like tightly adhered to the surface of our bones. So it's very, you can cut it off and kind of peel it away, but you would have to cut it and peel it away to actually get it off. So it kind of fits on the bone very very snugly. So they call that the periosteum, and you can see here in our picture they've kind of cut a piece of it and pulled it back so you can kind of see the periosteum. But just realize it's got these little fibers that attach it to the surface of the bone very well. So in the periosteum, we will look at the cells that make up the periosteum and their role in the growth of bone, as well as the remodeling or maintenance of bone too. So that's the periosteum. So we have periosteum that's going to be on the outside of the bone, kind of covering the compact bone. Now we do remember have that channel or open space that runs down the diaphysis, the medullary cavity. That we have bone tissue that's around that cavity. And so we do have a connective tissue called endosteum. Endo, E-N-D-O, means inside, osteum's bone. So we do have the endosteum covering the surfaces of the, like the spongy bone that's inside our bones. So the endosteum will be the layer that's on the inside of our bones. And again, mainly covering the kind of the lining, the medullary cavity area. And again, it has, just like the periosteum, has quite a few bone cells that we're going to talk more about in a later objective. But again, the bone cells in those, the osteocytes in those areas, will be involved in, again, healing of our bone and forming of our bone and the maintenance and remodeling of our bone. So, all right, so that is our video on our gross anatomy of our long bone. So the next thing that we'll talk about, I'm going to make sure we have plenty of time here, is the, not all bones, we kind of focused on long bones, but there's other shapes of bones in the body, and they don't necessarily have these gross features. They share some of these features, but not all of them. So that was our next objective, was to talk about the gross anatomy of other bones compared to our long bones. So I'm going to slide down here. So what they're going to show is a lot of the other shapes of bones, our short, our flat, our irregular bones. Those differ a little bit in how their gross anatomy works. So they're giving an example of a flat bone for this gross anatomy of these other bone classes. So this, we're looking at it looks like the parietal bone. So we're looking at the parietal bone, and if we take a section of that bone from the parietal bone, then we can see that we don't have a medullary cavity. We have spongy bone in the center, so you can see all the spongy bone, and then it looks like we got the compact bone that's on either side as well. But we don't have like a diaphysis or epiphysis or those structures related to long bone anatomy. We do have a periosteum, so we will have the periosteum that covers the surface of the bone. So they kind of pulled it back there a little bit so you could see it. But it kind of looks more like a spongy bone sandwich, kind of where the spongy bone is kind of just, in between two layers of compact bone. And so that's primarily the anatomy of our other shaped bones, is so just kind of knowing what structures, gross anatomical structures that these bones have compared to long bones is important. So, all right. So in the next video, we will talk more about bones, and I will see you in the next video.